Hello everybody, thanks so much for showing up today. Really appreciate you being here. As the slide suggests, my name is Todd Golding. I'm a partner solutions architect and I focus on, not surprisingly, SaaS as my area of focus. And when I'm working with partners and customers who are adopting or migrating to a SaaS delivery model, can we bring the mic down just a little? When I'm working with customers that are moving to those models, there are some common themes that I see and some patterns. And what we see is these organizations that are really hungry and interested in achieving sort of the promise of SaaS agility, right? They want faster delivery models. They want to be able to push out features faster. And a lot of this is really driven by a competitive need. They're really interested in saying, either they're worried about whether some competitor is going to come into their space with a SaaS offering and potentially move past them in a way that they'll get left behind, or they're just generally trying to create the gap themselves between the rest of the competition. And as part of that effort, what I find is some themes among those organizations that make them successful. And a huge part of that is the capture and the processing and the sort of correlation of a much richer population of metrics about how tenants are consuming their system, how those tenants are pushing and exercising the architecture of their environments. In general, this whole engine that fuels their agility and is at the core of the success of their agility ends up being driven by a bunch of metrics, and not metrics that are just technical metrics, but business metrics. And more importantly, it's often the correlation of these business and technical metrics that are at this core of this lifeblood of knowledge that drives both the technical and architectural and operational and business direction of the organization. And when I look at these organizations and I say, well, how are they using metrics? Where are metrics applied in their solutions? I see clearly a whole bunch of technical uses. So you'll see here on the architectural side here, I have a bunch of metrics that are here that are about, very unique to multi-tenant environments, by the way, a bunch of metrics that are about how does my system respond to peaks and loads, and how does my system handle new customers that are onboarding? Does it handle onboarding them fast enough? So I see SaaS architects obsessing over lots of metrics, and they're not just sort of looking at them periodically, they're looking at them all the time to decide, is my architecture efficient? Is my architecture responding and servicing the needs of the business? And in fact, for me as a SaaS architect, both at AWS and at other solutions I worked on, it was always fundamental to me to be able to go to the business and say, I am doing everything I can to eke every ounce of efficiency out of the architecture, because I know that the architectural footprint of our solution is going to have an impact on the bottom line and the success of the company, much more so than maybe other companies that I worked at. But you'll also see here, surprisingly, metrics having a huge impact on the operational side of the house. And the operations side of the house, I need some notion of how tenants are pushing my system, because in a multi-tenant SaaS environment where I've pushed everybody under the hood of one infrastructure, now the stakes are so much higher. Now if my system goes down, my entire business goes down. So what I see operations people, I see them mining these metrics at all. And we'll even look at in a few slides here, we'll look at the kind of operational metrics that people look at that are very unique to SaaS, that help you more proactively respond to issues before they're an issue to your tenant or before they bring your system down. So there's all these very clear sort of technical dimensions we look at, and maybe some of you are already looking at those today, but if you're not, you should be looking at those. But then the business is also looking at a bunch of metrics. They're looking at how are tenants using your system? What are the patterns in use? And now with all the tenants running in one environment, we'll see tenants are bottlenecking in certain areas, or aren't using certain parts of the system, and the business wants to know why. More importantly, you'll see tiering strategies here. We'll have a basic, an advanced, and a premium tier in our solution, and we'll find that without analytics, we don't really have a good sense of how are customers potentially moving from one tier to the next, and are the features we're putting out there and the capabilities we're putting out there driving them up that stream to the higher end, higher cost solution. So my big point here is that in a universe of metrics for SaaS, both the business side and the technical side ought to be looking at these bits very heavily. Now, The awesome part of this is that you put all your tenants and your customers under one umbrella. The ability to get to the metrics that they need, the ability to aggregate those metrics gets a lot easier, right? If you had a situation before where you had on-premises customers, you had some custom installed, maybe they're in your hosted environment, but they're very distributed, it was very hard to sort of collate and aggregate a view of those metrics that was really useful to you, and it was very rarely something you got in real time. So now that you've sort of got this multi-tenant infrastructure, you say, awesome, I get a lot of these metrics, I can get to them easily, I can surface them easily, and that's great. But you also run into a huge challenge here. And this challenge is a big part of the focus of this conversation today, which is, as a SaaS architect, I don't just want to know sort of the basic metrics everybody's tracking. There is a metric to me that is often the most important metric I want to chase, which is tenant consumption. I want to know how much load, how much effort every tenant we're putting into supporting every single tenant in our system. I don't want to just generally know the system is doing well, the system is responding to load. I want to know with the granularity of a tenant view what those tenants are doing, how they're pushing the design of my system, how they're pushing the architecture of the system, and guess what? I want to know how consumption is driving the business side of the house as well. There are metrics, those same metrics should mean a lot to product managers, right? So for me, I have become very obsessed as a SaaS architect with saying, I need to know what this is. I need to know this number. I have to be able to create some view of this. But here's the challenge. All the goodness that got us those metrics easy, make getting this tenant consumption number hard. Now that everything's in a shared environment, now that we're running in shared infrastructure, suddenly it becomes very hard to parse out what load each individual tenant is putting on your environment. Imagine you have compute instances, you have ECS instances, you have EC2 instances, and you've got tenants exercising them all over the place. How do I know which tenants are imposing which amounts of the load? How do I attribute consumption to them? That is the focus, and the focus on how that affects both my architecture and the business strategy of the house, and the focus of this talk. So hopefully that fits with the abstract you read and what you're coming for, because that's what we're going to talk about, is how do you get to there through a technical lens? How do I build that, the moving parts of that to get that solution? Now, before we dig into the mechanics, I want to be very clear with the difference between consumption and metering, because these two phrases, these two words tend to get conflated, and they tend to overlap a lot in the SaaS world, where people will talk about metering when they mean consumption, or they'll talk about consumption when they mean metering. And I think it's really important, because I think you could get lost in this terminology really easily. So when I talk about metering, to me, metering is pure and simple a billing construct. When I want to meter in a SaaS environment, my goal is to say, what are the things I'm going to track and follow to be able to, in the end result, figure out how much I'm going to bill a customer. And that mindset is a very different mindset, because here we might not even meter consumption. We might meter number of users or features, or we might even have some composite metric that is a composite of a whole bunch of kinds of consumption that is unique to my domain that ends up being the metric I end up billing on. So very different. My goals here are all driven by how are we selling the product, how are we billing for the product, and how do we measure that? On the consumption side, I think of the consumption side as more of an internal metric. When I think about consumption, I want to say, if I could look at in a moment in time and take a snapshot and look through my consumption lens, and I could see a line tracing through all of the architecture of my system, all my storage, all my EC2 instances, all the resources of my environment, and I could say somehow, I see that this particular tenant is consuming 22% of the resources of my system. That's what I'm after with consumption. And I, with consumption, want to be able to correlate that with your bill. Like, how much are you paying for AWS for those resources, so that I can come up with some metric that is a cost per tenant. And that's my magic metric here is, could I say to the business, the cost per tenant in our system is this right now? And then you can imagine a bunch of derivatives, that average cost per tenant, and you could start trending into string things with cost per tenant. And so consumption can certainly overlap with metering in this discussion, because some people who sell storage as a part of their SaaS service are certainly going to measure your consumption of storage as a way to arrive at your bill. But that's just sort of the natural area where they're going to overlap. I prefer to see one as billing and one as more of an internal metric. Now, last little sort of building my case sort of moment here. I want to talk about a specific example I had where the usage of this consumption metric meant a lot to me and had a lot to do with driving my thought that this is a metric that I think every architect in the SaaS world should be chasing. I worked at a SaaS e-commerce provider for a few years, and we basically sold a e-commerce system where merchants could come in, build their own storefront, have their own card, customize the look and feel of it entirely, and sell their own products. But that was all run on a common shared infrastructure. And when I got there, the company seemed to be doing quite well. They had lots of merchants in the system. They were moving lots of product. They were acquiring lots of new merchants all the time. But for some reason, when you looked at the actual books of the company, they weren't doing so well. And I'm like, what's the deal? I don't get it. And I'm asking questions of people like, what's behind this? Why are we not doing better? Where's wrong? So I thought I'm going to at least go away and do my part as an architect and say, I'm going to go try to figure out how my part of the problem is contributing to this, or as it might be playing a role in this. And we went away, and the system that we were working on had a basic tier, a standard tier, an advanced tier, a very common construct. Basic tier was like $49.95 a month, and advanced tier was maybe $5,000 or $10,000 or whatever it was. And we had features that distinguished one tier from the next and tried to get people to move up that pattern. And so when we started to try to mine data, try to understand what was going on here, we went after 3 specific things. We actually went after more than 3, but these are the 3 interesting ones to me. Catalog size. We said, how many products are in their catalog? What's the diversity and the selection? Because maybe they're just having varying success based on the number of products they're offering, and that's just not driving enough business or something of that nature, and maybe that's why they're succeeding or failing. We're also going to look just generally at how much sales they're doing on their e-commerce site, like how much product is actually selling, because we actually get a little cut of that sales, and that actually hits our bottom line, so we want to see what the correlation is there. And then the last thing is this tenant consumption number. Like, okay, how do we correlate these tiers? Or we actually did it to the tenant level, but then did it to the tier level. How are these tenants contributing to our infrastructure costs? And when you look at the graph, you can kind of see the trend here that sort of jumps out at you. It's pretty obvious, right? If you look at the advanced tier customers had these really small catalogs. They were selling these niche products, but they were great at selling the products. They knew how to market them, they knew how to sell them, and they were moving lots of revenue. And this revenue certainly was pushing some transactional bits of our platform. But overall, they were barely contributing to the infrastructure footprint cost for us. Their cost per tenant was low. But then you look on the basic tier side, we saw these people who were like, I don't really know how to run a business. I'm just going to try everything I can. I'm going to go and hit your API like there's no tomorrow. I'm going to upload all these bizarre products, and I'm going to and just hammer your API. I'm going to hammer your store design bits. And so they exercised the heck out of our system, but they moved hardly any revenue. And of course, the big number here, they were just absolutely consuming most of our infrastructure costs. So here at one end as a basic tier customer, they're costing $49.95 a month for us, and they're absolutely eroding all of our profits. And as soon as I had this sort of data, and I could go into the business and show this data to the business, which I think anybody would love to be able to walk into the business and say, look what I found out. Somebody's going to have to say, well, we're doing something fundamentally wrong here. We're not doing something to throttle these basic tier users. We're letting them just go wild and letting them push our infrastructure without any kind of controls or any sort of limits on what they can do. And so they're rising our costs up, but not contributing anything new to the bottom line. And so even though you're acquiring new tenants all the time, as long as they stay in that basic tier, you're kind of stuck. And the business loved this. And they fundamentally went back and said, changed their tiering strategy, changed their limit strategy, changed the way they priced the product, and shifted this more. And suddenly, these basic tier people couldn't get more infrastructure resources without paying them more of a premium. and now we were in good shape. So to me, this is just one example of tenant consumption, but to me it was a very compelling example of tenant consumption that really gives you a sense of, why do I need this number? Now, I mentioned the value of operational, these metrics to operations. I think this is a hugely overlooked opportunity for companies, right? I have the ability to, if I can get tenant consumption metrics, to surface an experience that can be very helpful to my operational staff, right? And so I put together this little wonky dashboard here that is just trying to give you a little bit of a view of some of what I might do in real time if I had tenant consumption data. On the left-hand side in the top left corner, you'll see that I have some notion of who my most active tenants. So if I have this tenant consumption data, I can say who's pushing my system right now the most. I can have a top 10 list or whoever it is. And more importantly, what is the health of that tenant? What is the experience they're getting, right? If I've got all kinds of red and my most active tenants are red, something's wrong here. Like the people who are most using my system are having the worst experience. I've got to go do something about that. Now, a totally separate view of this is to say, on the right-hand side, what is tenant resource consumption? So here I'm going to look at the individual resources of my system, compute, storage, whatever sort of notion of services that you're consuming in your system, and say, how are tenants consuming each of those resources? So to me, it's super value in an operational context to be able to say, wow, Hogwarts memorabilia is consuming 27% of my compute resource right now. And it might be some other tenant is consuming some disproportionate amount of your DynamoDB resources. If I can break this out along these dimensions, these usually end up being red flags that the operational people can go back and say, hey, something's funky in the architecture, or this tenant's doing something we don't normally see. We need to dig in here and find out what's going on, because what we're doing is just turning up the PI ops every time they push DynamoDB harder, when in reality we're turning them up for one tenant. Not a very smart move. The last one is maybe more debatable, but to me is one of my favorites actually, which is this notion of service activity. To me, I decompose my system in all these cool microservices. I build, in this case, it's e-commerce. I've got catalog, shopping, and product, but whatever your microservices are in your application, and I go to all this effort to build cool boundaries around them and make them scale and encapsulate storage. Well, I also want some view of how tenants are consuming those services. So this view at the bottom is trying to say, who are the top consumers of the individual services of my application? And why is somebody potentially disproportionately using one service over the other, right? And yes, it could just be that one tenant uses more of the system than the other, but what I tend to find is you find very bizarre and interesting bits in here, and I see operational people building proactive policies around these metrics. They'll say, hey, every time this starts to happen, I'm going to go do something to have the environment sort of auto scale or adjust some policy to be able to say, I'm anticipating an issue here. I'm going to react and respond before it becomes a huge issue. The last one, and I think developers can very much relate to this. Imagine having this metric and being in a room with a product manager who has an idea for a new feature. Well, actually, maybe the better example is to say, imagine you don't have this metric. The product manager's in the room, and the product manager says, hey, the competition is doing X. We want this new feature. Let's go do it. Here's how it needs to work. And you race off immediately to what it is and what it needs to be. And there's almost no discussion of, well, how's that feature going to affect cost of the system? Like, what's that going to do to our tenant consumption profile, right? So you just keep adding on features, and without this metric, you have no idea whether the feature you just added might have just upped your infrastructure costs per tenant by some huge amount that nobody thought about. Now, for some features, this is more obvious than others, and it becomes part of the discussion. But what I want to do is say, I'm going to equip the product management side of the house with the knowledge and get them used to this idea of cost per tenant, and get them to start thinking about that as they start thinking about what new feature they want. I want them to start asking me, like, how is this going to affect our tiering strategy? Is this a good strategy? Should we only make this feature available to certain tiers? How is this going to affect the bottom line cost model? Do we need to raise our costs if we implement this feature? I want that to be as much of their vocabulary as what the feature will do and how important it is to the market. So to me, this is using that knowledge and extending it into the business as an architect and making it a part of their view and putting it in their face in a way that they can act on it and make it part of their decision-making process. Now, enough about all that. Let's talk about how you might implement this consumption, right? And there's some really simple models of consumption here that we can start with that are really obvious. And if you have these, you're golden. You don't have to do a whole lot of work, right? If I'm in what we in the SaaS world called a siloed environment, where every tenant gets their own stack of resources, my notion of cost and my ability to do cost per tenant is a much simpler discussion. In fact, what we'll often see people do if they don't have too many tenants is they'll use AWS linked accounts, and they'll put each tenant in a linked account, and they'll use the AWS billing constructs to pretty much build their bill, and they'll know cost per tenant, done, hooray, you win, you've got everything you need to know. Now, you have a pretty costly infrastructure probably as part of that because you're not sharing infrastructure, but a totally valid approach to this. So another approach to this is to use VPCs. So same idea, siloed tenants, all the infrastructure is in a silo, but instead of using a linked account as the construct, we're going to use a VPC. So we'll put them all in the VPC. We might do something with peering, where we'll do peered VPCs as a way of managing each tenant VPC. And then we just say, well, now what's the AWS construct? We're going to use this. Well, now we use tags, right? Tags are a pretty natural way to say, tell me what all the resources are in that VPC. They still all belong to this tenant. I can still derive a billing construct from that pretty easily. So with these two models, if you're in these universes, you can go back and you can just start to grab these numbers. Now, what you will find here is that these numbers, because they're siloed, are less actionable in some of the other contexts, right? Now, the more siloed something is, the less you tend to care about the system going down because it's usually only one tenant going down. Nobody likes one tenant to go down, but that's certainly very different than the entire customer base is down. So the investment here tends to be less, but still a valuable number to go after. Now, where it gets a little more interesting is when you end up what we call the bridge model, right? The bridge model is one where layers of your architecture are using different schemes here, a mix of the schemes that we've talked about. At the top here, and this is kind of a traditional monolithic architecture, I have this pooled web tier where I've got a bunch of web servers. Those web servers are all shared infrastructure for all the tenants. And then at the app tier of my solution, I've said, no, those have to be siloed. So at the app tier, each tenant gets their own cluster of application servers. And then back down at the storage level, the storage tier is pooled again. Well, for all the siloed bits of this, we get the same sort of rules that we just talked about. For the siloed bits, I have ways to go away and pretty easily derive the cost. But what do I do for the pooled resources? Like, what do I do for that web tier? How do I go? AWS doesn't give you a construct to say, where do I derive consumption in that pooled web tier where all the tenants are running in the shared infrastructure? That's where this problem gets hard, and that's where we need to focus a ton of our energy on what are the strategies we have here, because there is no textbook answer to this problem. There's no sort of framework or tool or some white paper somebody wrote that said, here's how you derive consumption in a shared infrastructure model. You have to sort of come up with it. I'm pitching some ideas for that I think here that you'll see in the coming slides, but I also think you'll have to be innovative on your own to come up with strategies for this. So the question is, okay, let's start with the simplest model. Let's say we have an EC2 instance, and we have an EC2 instance that's running some service, probably part of some cluster, and it exposes it's being executed, it's got some app running on it that's exposing some kind of REST API, and tenants are exercising that REST API in tenant contexts. But they're all just calling it, and when you look at the distribution, if you could somehow know the distribution, which is the problem we're trying to solve, you would see, hey, tenant 5, for example, in this view, is consuming way more at this moment in time of this EC2 instance than, say, tenant 1 or tenant 10, right? If I look 20 minutes later, I'm probably going to find that that distribution might look entirely different. So what strategy can I use when I have this sort of model to derive consumption? And I'm going to say an important word here to me that hopefully stays with you through this whole thing. To me, what are you going to do to derive an approximation of consumption? Because my belief is you should not be targeting absolute sort of notion of consumption. I don't believe at least there's an algorithm or a strategy yet that I've come up with, and I'd be glad if somebody has one, share it with me when you're all done, but that will be so precise as to say, I've absolutely nailed and I can tell you down to the millisecond who's consuming this resource and how much. So instead, we're going to go for some strategy that is an approximation here. So then what are the ways you could approximate consumption here? Well, to me, they kind of relate to, well, what's the amount of activity going on? What is the amount of activity somebody might be requesting of this service? Well, there are ways I can measure that. Request count could be the easiest one, right? You say, oh, this is a really simple service. Everything it's asked to do, it can respond to and react to and very quickly. And so I'm just going to count the number of requests per tenant, and that'll be my distribution. And I'll figure out, hey, this tenant did 10,000 requests. This tenant did 4,000. I've got my breakdown. I can do some distribution based on that. But that may not be the right answer, because somebody else might say, I don't care how frequently you call. There's some of the methods in there that are super intense methods. And those methods impose a really heavy load on the instance, and that's the better measure of consumption. So here I might look at latency. I might say, how long did it actually take to process that request? And use that latency as the unit of sort of figuring out how I'm going to apportion consumption for this resource. Now, you could look at CPU impact, you could look at memory impact. Like I said, inexact science, but these are some of the strategies that seem to make sense for me for figuring this out. And if we live in the world of approximation, we might be comfortable with those. The other thing we have to think about here is the fact that the strategies per service are not universal. What I do for EC2 versus what I do for DynamoDB, or what I might do for Redshift to apportion cost or to determine the amount of consumption. Imagine a managed service versus an instance is a very different mindset to just say, how do I apportion consumption in that sort of universe? So I have to have different strategies for the different services that I'm leveraging, and I'll aggregate all that into some notion of cost per tenant. The other thing I have to think about is the services, the microservices, whatever the flavor of service you've decomposed your application down into. Each one of those services can have a different strategy for how you decide to apportion consumption. Catalog might look different than cart. This same theme, by the way, applies to auto-scaling if you think about it. Some things need to scale on CPU, some things need to scale on memory, right? You have to take the sort of nature of that service, figure out what the right policy is for it. The same thing is true here. You have to look at these individual services and say, hey, request count's good on this one, and latency is better on this other service. Where I don't want you to go crazy is to say, hey, I need this menu of 50 strategies, and I'm going to spend a week thinking about every service and figuring out what's the ultimate strategy for that service. Come up with a menu of 3 to 5 approaches, pick a few that seem to make sense, and in the mindset of approximation, you'll probably be good enough, and apply those uniquely. I just don't want you to say there's one strategy and it applies the same universally to all services. So what's this look like behind the scenes? Like, how do I get to this number? What sort of infrastructure, what sort of implementation strategy I have here? Well, if you think about what you have to do here, it's not all that different than what you do when you're logging or raising any other kind of metric or building any sort of metric instrumentation process, right? You need some way to instrument the actual moving parts of your application with the frameworks or the libraries that are going to allow somebody to surface the metric. And then you need to feed that into some scalable kind of mechanism that can accept that data at scale, feed it through, aggregate it up, and store it somewhere so that some BI tool can go consume it and give you answers. And this is no different than that. So fortunately, there are a ton of patterns for how to do this. This is one very simplified one here, which is I've taken an application service, I've instrumented it with some framework of mine. Language choice here might be a module, it might be a jar, whatever it is that you're using out there, whatever language construct. And I'm going to instrument this environment with some key metrics that I can use to go derive consumption. Most important metric here, tenant ID. If I don't know which tenant ID is here, I have no notion of which tenant to associate this consumption with. But then I'm also going to catch maybe the method they called, the latency for the processing that call, and you can imagine date and time and a whole bunch of other data points that I might put in here that could help drive my consumption metrics. Now, once I have that data, I'm just going to feed it into this pipeline. In this example, I picked one of the models you could use. This could be the Elk Stack, and it could be Redshift. It could be any number of different stream-based models for capturing events. But here I'm going to shove it into CloudWatch. I'm going to use Lambda to pre-process it, feed it into Kinesis, and then eventually dump it into S3 and say, okay, the data's all there. Now some aggregation service can go grab it and do something interesting with it. Now, the thing I would like to see people do is say, however you instrument it on the left, right, that you are putting the richest set of data that you can there. Don't presume exactly how what model or policy you're going to use to derive your consumption numbers. Instead, say, let's just instrument it with as rich a data as we can, and then when it finally lands in S3 and I decide to aggregate it, if today I'm saying, hey, this scheme seems to be working pretty well as an aggregation scheme to come up with distribution, awesome. But if tomorrow I say, you know what, there's another data point that seems to contribute to consumption as a better data point, and it's available to me there, I can start to play with it. Because I guarantee you, as you start to play with this concept, you'll be wrong. You'll see your first set of numbers on consumption, and you're like, that doesn't fit at all. That's not what my tenants are doing. And you'll, we factored this wrong, or our algorithm was wrong for how we did this. Well, now are you going to go back and re-instrument because you need a new piece of data? Well, you could do that. I just like to keep those two separate. Ultimately, when you're done, you end up with some distribution here that says which tenants consumed which percentages of this particular service. And that gets us a little ways down the road towards this problem. Now, it wouldn't be fair to talk about this without talking about what this would mean in a serverless model, because if you catch me anywhere in halls or talking about SaaS anywhere, I will tell you I believe that SaaS is a fantastic fit for serverless, right? Those two line up very nicely. I have another talk that I've done on serverless and SaaS and talking about the alignment between these two. So what does it mean then to apportion consumption in a universe where you're building a serverless application, right? So I've got an API gateway, I've got my catalog service now represented as a series of individual Lambda functions, and each one of those Lambda functions are executed by tenants in an individual tenant context. We're no longer sharing some compute resource, ECS or EC2, we're sharing that compute resource. Here, that function will execute in the context of that tenant. Well, now, because I have this sort of one-to-one mapping of tenant to the method that executes, my ability to derive consumption gets a lot easier, right? I just have to know how many times you called that function, and I have a much easier way to get to consumption number. So to me, this is yet another sort of box to check for serverless to say, by the way, consumption is also easier to do here. That doesn't mean you don't have to go build all the infrastructure to capture and aggregate it all, but I think your math and your mechanisms for figuring out consumption get easier here. The other thing I want to point out here is that this doesn't have to start out at least, as something so granular as every service is somehow instrumented and you've gone after every service and you've gone after every detail, some very sort of granular view of consumption. Instead, you could put something at the edge and just capture the interactions with the services and say, hey, it's not 100% accurate, but it's better than having nothing. And so for me, API Gateway is an awesome opportunity to do just this. If I use the API Gateway and I put my services on my application on the other side of the gateway, and I take those REST entry points that are all the REST entry points to my services, and I wire them up with instrumentation to raise the same metrics, because I can get latency, I can get some of this other data out here, I can get tenant context out of here, and I ship that data off to my aggregation scheme, I have some notion there of consumption, right? It's not as precise and as granular as the other models we talked about, but it's a really good place to start. So to me, if I said do nothing else, I'd go away and do something like this. And it doesn't have to be API gateway. Is there some edge, some entry point, some managed API experience for your product at the outer edge where you could do this as a starting point? Because maybe you get this data, and I guarantee if you start to get this data and you think it's doing interesting things for you, somebody will want the next level of data from you. Another approach to this, I was working with somebody on my team named Andy Powell, and he was working on Java annotations as a way to work with AWS X-Ray. So those of you not familiar, AWS X-Ray is a tracing tool, so it will essentially capture an end-to-end trace of a whole bunch of functions in your application, and it will tell you things like latency, and you can inject into the annotations while it's capturing these bits. And we started looking at this tool just as a cool tool for SaaS so that I could say, oh, let's just see traces of what tenants are doing in my system. And then we said, well, it ends up being a repository for some very interesting data that could be a way for me to calculate consumption. Could I go and just take this data, take the latency of the calls in my app, do some algorithm against that, and say, that's an approximation of my consumption? And the good news on that is, you now have a lot less infrastructure because X-Ray is now housing that data. Now, I think you'd probably pull the data out of X-Ray and put it into something that was a little more BI friendly maybe than X-Ray. I don't know, I haven't looked at the footprint for pulling the data out of X-Ray closely enough. But I think it's also a compelling alternative to going super deep here. Now, where this gets more interesting is when you start talking about other services like storage. The storage isn't as straightforward as compute. Now when I get an AWS bill, I get different line items for different bits of storage. Like for DynamoDB, I might be paying for IOPS, but I might also be paying for physical size of the data. There are multiple dimensions along which I could get billed for storage. So now, unlike compute, where I can just say, tell me how much that I consumed of X, I have all this other data about that storage footprint to go calculate. Well, for size, the good news with size is it's a pretty concrete piece of a number, and it can be acquired at some point for a tenant. IOPS is harder. How do I know who I should give how much of the IOPS to? It's probably some variation of what we talked about with the compute services. Some notion of the frequency of the calls, some notion of determining which tenants are more active than others, apportioning that, and saying, that's how I'm going to apportion your IOPS contribution. Now, to get the storage aggregation, there's no secret sauce here. There's no magic. Ultimately, this is less about sort of eventing metrics out as much as it's more maybe of a pool model, because really all you want to say is, how frequently do I need this number? Do we do some daily thing where we're interested in this? Do we do it only when we do a billing cycle? When do we do it? I need some sort of aggregation service that can go out to the individual compute resources and say, what's the current consumption for this tenant? And get that number. And then I can say, this is the distribution of data size, at least, footprint size for a given service associated with a given tenant, and gives me some way to connect that to their bill. Now, there are two approaches to sort of figuring out what you want to do with this. There's probably more than two, but there's two that jump out at me. You could decide, you know what, IOPS and data size should be separate metrics. They're interesting to the business separately, and I'm going to leave them separate and never do anything else with them, and I'll just look at the frequency data. I'll come up with some IOPS allocation and say how much each tenant contributes to IOPS, and then I'll go aggregate the data sizes, and I'll say how much does each tenant contribute to the data footprint, and stop right there. The other option here is to say, no, the business wants some normalized composite view of consumption. They want to say, what's DynamoDB costing us? And they don't really care about IOPS versus size versus these other granular bits. So normalize that for me somehow and turn that into here's my normalized DynamoDB consumption number. There's no right or wrong to any of these strategies. You have to do the underlying number anyway to get the composite number. So the only question really is the composite number of any value to you? And what I do see people doing is they invent composite numbers that are new ones, sometimes out of their own domain. For some businesses, though, the IOPS are irrelevant and the size is like 99% of the cost, and so normalizing it doesn't add a lot of value there. My bigger point out of all of this was to only illustrate that as you dig into each type of service, there are this range of new considerations, this range of new things you have to think about to get to allocation. Now, the problem only gets more challenging. There's lots more services we haven't even talked about here. Athena, Kinesis, lots of apps are certainly using SQS and SNS. They're a big chunk of this. And I think I see SES used a fair amount as well. Do I go off and invest a ton of energy in apportioning consumption across all of these? Well, it kind of depends. To me, most organizations, at least for me as an architect, I usually have a good sense of, hey, Dynamo and compute or whatever, there's these 6 or 7 areas of our system that are 90% of our bill. And yes, we do a ton with SQS, but as a percentage of our overall bill, it's so small that even if I invested a ton of time and energy in figuring out what the cost was for it or the breakdown of per tenant, it would have hardly any influence on the final number I come up with. So my advice here is to say, for some services where you know they're not going to make a big contribution to your number, even if the tenant sort of consumption varies for that service, just do an equal distribution across that service and call it a day and move on. And then somewhere in the future, if you're suddenly seeing, wow, SNS is doing some interesting things to our bill, and these tenants are doing interesting things in ways that are affecting consumption in interesting ways for us, now I'll go off and figure out how I want to apportion S to NS costs and attribute them to that. The other one we talked about was services, individual services of your application. I think this one I would go for every time, and it's, again, I think it's my personal bias, but I've always loved seeing this number on my dashboard, is knowing how the actual microservices are contributing to the consumption profile on a tenant basis, right? And so in this model, you have to do some extra work here, or you can just decide, hey, I'll just look at frequency of activity and latency or something for that service. I won't care what's under the hood of that service, and that'll be an approximation of consumption of that service. Or I'll say, no, I need to look at the storage that's used by that service. I've got an example of a catalog service here using RDS and S3. I may go look at the consumption of those as well and do some way to normalize both the use of the compute and the storage to come up with some idea to say, what's the tenant consumption for this particular service? But I personally have seen my design and my architecture. I've even broken my app into new microservices because of the data points I've gotten out of this discovery. Now, once you have this data, there's some interesting things you can do with it. Once I figure out consumption, I can start to correlate it to other metrics. And what the business starts saying is consumption isn't just good because we know how much a tenant's costing us. I've got usage metrics as an example. I know where tenants are getting stuck and bottlenecked inside the application. And suddenly I start correlating some of the bottlenecks and some of the challenges in usage with consumption, and I find out, gosh, when this tenant's loading the system this particular way, I see this correlation to where they stop using the system because this particular service is not working well for them. So I'll start to see a business sort of technical intersection here that's a very interesting one. So I like to see you think of this as a first-class metric that you put alongside all the other metrics that you're gathering and start looking for new and interesting ways to correlate to those metrics. I also would like to say, just generally for metrics here, once you have consumption, start looking across the AWS stack at other things that might be interesting to correlate with it that you may not be aggregating today. There are plenty of sources for data. CloudTrail, if you don't use X-Ray the way we described, X-Ray may still be an interesting piece of data to put into your dashboard and your view of metrics. And CloudWatch, obviously, if you look at just general AWS standard metrics, are interesting to bring into this environment. The whole point is to create this BI service where you're able to correlate all of this data and build interesting views of this that are really creating sort of this real-time dynamic where people are making decisions in real time based on both consumption and consumption's correlation to these other pieces. Now, the hard part of this, well, the hard part was certainly figuring out how you're even going to do consumption. But even after you get consumption, there's another challenge to this. We still haven't talked about how that really relates to the bill, right? We know that a tenant's consuming X percentage of our resources, but that doesn't give us a cost per tenant. That just gives us some percentage of consumption. We still have to go out to the AWS bill, and we have to somehow bring that bill in, and we have to bring it in. If we're doing a siloed system, I wanted to show here that you could just use the tagging or the account scheme or whatever you do to get a total cost per tenant for silo. But more importantly, we've mostly talked about this pooled mechanism at the bottom here, which is, hey, we need to somehow go and figure out what, for all my tenants that are pooled, what's the total cost for those tenants? And what am I going to do with those numbers? Well, I'm going to do some very basic math. It's very straightforward here, which is I'm going to take my aggregated pool costs, I'm going to multiply them by whatever the allocation of my tenants are, and I'm going to arrive at some distribution of that tenant cost. And there's my cost per tenant as a magic number. And if I'm running in an environment where I've got pooled tenants and siloed tenants, I'm going to be able to, I might choose to aggregate all that up and come up with some total cost per tenant that spans both those universes. So the bottom number is just some way to show that you could aggregate those two concepts. Now, what I will say is this work on the detailed, getting the billing report and pulling the billing report in and aggregating that data and figuring out those costs, I'd rather not see people spending energy and time on that. It can add way more to your investment on this effort. So I'd like to see you going out to partner solutions and other vendors who are already good at aggregating that data and use them as the resource that is good at sort of getting you the billing sort of information, and then all you have to do is worry about how to apply the allocations to it. Because to me, if you've ever looked through the AWS billing constructs and looked at ways to aggregate them, there's a lot of moving parts to that. And so generating a bill that is a meaningful sort of bill out of that is a lot of work, and not a lot of work you may want to invest for this. So I talked about this idea of approximation. I just want to hammer this point home. This consumption metric, I don't have this sort of idea that these are absolute numbers and I've just nailed what this consumption is. I know down to the general ledger sort of credits and debits kind of level mindset here that I've absolutely to the penny figured out what your cost per tenant is. Instead, my mindset is that I want to be good enough here. I want to be able to say, these numbers are driving the value prop that we wanted to drive into the business. I'm targeting the right kinds of information, and I'm exposing the right kinds of consumption metrics that are valuable to my business. And then just challenge yourself periodically, reassess where you're at. Challenge yourself to see, should I be going deeper? Should we be more granular? And like I said, if you want, just start at the outer edge even, right? That may be good enough for you. So what are some of the key takeaways from this? Well, hopefully, just generally, if you're already not a metrics person and you're in the SaaS world, hopefully you see that you ought to be a metrics person. Like, you ought to be hunting for metrics. You ought to be trying to gather all the metrics you can, because even if you're just on the technical side of the house, you should see that metrics are going to have a huge impact on how you shape your architecture and how you sort of help inform the business and drive business decisions based on how those metrics tell you more about how the system responds and how efficiently it responds. Hopefully you'll also get the sense that consumption and metering are different concepts. So if you're doing metering today, that doesn't necessarily mean you've solved this consumption problem. The other bit of this is that this tenant tenant-centric metrics, these consumption metrics that we talked a ton about here, they directly have an influence on your operations side of your house, right? Hopefully you saw that dashboard that we had and we talked about ways you could surface these operational metrics. These can be real-time metrics. They can affect scale, they can affect availability, so they're not just sort of about, I'm finding some interesting trends that once in a while we'll look at. They might be useful, they might not. To the operational side of the house, these become critical metrics. When you go down this path, you do have to allow for the fact that different services, different AWS resources, each one of these things may require a different consumption strategy. And part of that strategy, hopefully you realize, is you don't have to sort of boil the ocean. You can pick the services where it makes the most sense to target at first, and then do an even distribution in other cases. This last point just is the point we just hit on. If you're going to go get billing data, correlating that billing data is a challenge. I'd like to see you offloading that to a partner solution or somebody else and letting them own that API and that experience. And then, if nothing else, take the last point home here is start small. Just demonstrate value, get the business to see the value of these metrics, get them engaged with wanting to know what they're about, get your product managers thinking about these metrics, and get them to realize how important these metrics can be to the bottom line. So, just some additional resources that may be of interest to you. There is a quick start solution that I don't know if any of you knew launched out there. I didn't put the link here, but if you search for this SaaS, Identity and Isolation with Amazon Cognito, it is an end-to-end reference SaaS implementation that is doing some interesting things with identity, but it's also doing interesting things with isolation. I only put it out there because you're a SaaS crowd. I assume you have interest in SaaS. You might be interested in looking at this. And I have a session at the end of the week that also dives very deeply into the implementation of this. In terms of other sessions, I've got another session on identity later, I think in another hour here. And a colleague of mine, Judah Bernstein, is doing, I think at 5 o'clock, this GPSTEC309, where he looks at New Relic and he looks at multi-tenant health. It sort of marries nicely to the topic that we just hit here, but it focuses more on how can you surface these things in a partner experience and instrument your app to get them to show up in those bits. And then, like I said, the Friday session I had. So, thank you so much for coming. Hopefully you're interested in tenant consumption metrics. Not always the sexiest thing, but a metric that's very important to SaaS businesses. Thank you very much.